See students, we are starting Science 1 chapter number 2, periodic classification of elements. In this, we have already studied about the basics, the Dobrino's law, Newton's law of octave and its limitations, the Mendelev's periodic table, its merits as well as demerits. Now we will be studying is a modern periodic law which is given by Henry Moseley in 1913 AD. He demonstrated an experiment using an X-ray tube that the atomic number Z of an element corresponds to the positive charge on the nucleus or the number of protons in the nucleus of the atom of that element. This reveals that atomic number is more fundamental property of an element than its atomic mass. See, earlier you have studied that the scientists have arranged the elements in the increasing order of the atomic masses, that is A. But Henry Moseley has arranged the elements in the increasing order of the atomic number Z. So the property of an elements are a periodic function of their atomic number Z. Modern periodic table is also called as long form of periodic table. The classification of elements are arranged in an increasing order of their atomic numbers in the modern periodic table. The properties of elements can be predicted more accurately with the help of modern periodic table formed on the basis of atomic number Z. Most of the drawbacks of Mendelev's periodic table were removed, but ambiguity about the position of hydrogen is not removed even in modern periodic table. The electrons are distributed in shells around the nucleus is determined by the total number of electrons in it, and the total number of electrons in an atom is the same as the atomic number. See, you have seen this atom and these are the orbits where this corresponds to the different shells of the atom. The relation between the atomic number Z of an element and its electronic configuration is clearly seen in the modern periodic table. See, about this electronic configuration and about the shells of the electrons of an atom, we will be studying more detail in further part. The next is the structure of modern periodic table. The modern periodic table consists 7 horizontal rows called periods that are 1 to 7. You can see here. These are 1 to 7 called as periods. Similarly, the 18 vertical columns in this table are called groups that are 1 to 18. You can see here. These are 1 to 18 called as groups. The arrangement of periods and groups result into formation of boxes. You can see these are the boxes, small. So the combination of these periods and groups forms boxes, and the atomic numbers are serially indicated in the upper part of these boxes, and each box corresponds to the place of one element. Each box corresponds to one element. See, this is one box which corresponds to hydrogen. This is the another box which corresponds to helium, as well as here are several boxes which corresponds to one element. See students, it means that there are 118 places for elements in modern periodic table, and very recently formation of new elements was established experimentally, and thereby modern periodic table is now completely filled. You can see here, this is a modern periodic table which has been now completely filled. There is the lanthanide and the actinide series which is shown at the bottom of the modern periodic table, and this whole periodic table is divided into 4 blocks, that is S block, P block, D block and F block element. Okay, here I have shown this S block, this D block, P block and this F block element. S block contains group 1 and 2. The group 13 to 18 contains P block. Group 3 to 12 constitute D block, while lanthanides and actinide series at the bottom forms the F block. See, here you can see this 1, 2, this is 3 to 12, this is 13 to 18 and these are at the bottom which are actinide and lanthanide series. A zigzag line can be drawn in the P block of periodic table. Here you can draw a zigzag line. All metalloids lie along the zigzag line. All metals lie on the left side of the zigzag line, while all the non-metals lie on the right side. See here. This zigzag line here which divides the metals on the left and non-metals on the right hand side. As well as the D block consists all transition elements. See here you can see now in more detail. Here it is shown the zigzag line where all metalloids lie on this zigzag line, whereas metals are here and the non-metals are here. This zigzag line divides the metals from non-metals. See students, if you consider one example, let us take beryllium, where this 4 corresponds to atomic number which is Z, and this 9.012 which corresponds to atomic mass which is A. If you take another example, here manganese, where this 25 corresponds to atomic number Z, whereas 54.938 corresponds to atomic mass which is A. So you can see in this periodic table it is being arranged in the form of atomic number Z. You can see this is 1, here it is 2, 3, 4, 5. So it is going on increasing in this way. Okay. So from 1 to 20 elements you have to keep in mind, starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. This 1 to 20 element you have to learn by heart. Along with that, the alkali metals which is lithium, sodium, potassium and so on, alkaline earth metal which is beryllium, magnesium, calcium and strontium, so on, then halogens which is fluorine, chlorine, bromine and so on, and noble gases like helium, neon, argon, krypton and so on. Along with that, some metalloids, that is boron, silicon, germanium, arsenic, this also you have to keep in mind, and some of the metal which is iron, cobalt, nickel, copper and zinc. This also you have to keep in mind along with that 1 to 20 elements.